Hey everybody, it's Sean Davis here. I am a content creator for Eclipse-Astro photography on Instagram, and this is part 2 of my video tutorial series that I'm creating on Pixen's site. Then the last part we discussed how to do cosmetic correction and integrate our raw data from NGC 6744 Spiral Arm Galaxy and create our master files as you can see here. So we have a superluminance, our blue, our green, and our red. So what do you do with these? Well, the next step is what I do is dynamic background extraction. You can find that in process, background modelization, dynamic background extraction. You go to your file, make sure, click on it, and that activates this dynamic process for that frame. Now, the numbers I use a tolerance of 2, and if there's not if I'm not doing a big wide field nebula, or if there's not a lot of nebulosity that I need to worry about removing, then I'll just do a relaxation of 3.5. As this is a galaxy, I can get away with that. The sample generation, you are drizzling, so you need a little bit of a larger sample size. And then what you want to do is you want to select areas of background. You see right here, and want to avoid bright stars, being near bright stars. You definitely do not want to go clicking into the galaxy, as it will remove that background. So this is basically just going to take an average of the background and try and neutralize it, try and remove any gradients that may be in there, etc. It really is beneficial. It cleans up the image substantially. If you do it well with noise polluted areas, it can really help with that as well. Adam Block does a few really good tutorials on how to use dynamic background extraction quite creatively. So I do highly recommend beginners to go and check out his videos. He is a very well renowned and very knowledgeable astrophotographer, and he was quite the tutor for myself watching his videos. Okay, so once you have found a sufficient amount of sample points, and you're going to change your target. You can do it either by division or subtraction. I tend to just use subtraction. And then I discard the background model normally, but for this one I'll show you what this is actually doing. And I'm going to replace the target image. Another little trick to save the instance like that by taking the triangle and dragging it off, and that way you can apply this to all your filters separately. Click apply. And if you stretch that, you can see this is all the gradients that it has removed from the image. Now it doesn't look too pretty, but you can change that. To be honest, I can't remember how to do it because I don't usually worry about it. You just change the bit format. Anyways, you just change the bit format and it will smooth it out. But you can just discard that. Hit F12 to disable STF auto stretch, and then put a new stretch, and you will see the image with the new background extraction completed. And you want to do that to each of your filters that you're going to use. So we'll apply. Again, F12, apply a new stretch, and do that to each one. Okay, so now I have all my files completed with the background extraction. The next step is to take your RGB files and make a color image. To do that, you're going to go to Channel Combination, and you're going to select your source images. Red for red, green for green, and blue for blue. If you're using narrowband images, you can make your narrowband palettes through here by adding your hydrogen alpha, oxygen 3, and your sulfur 2 files in here in your chosen palette. So say a SHO Hubble palette, you would put your hydrogen or your sulfur 2 in your red channel, your hydrogen alpha in your green channel, and your oxygen 3 into your blue channel. However, this is a galaxy, so we are in LRGB. Apply global, and you will be presented with your new image in color. Well, wait a minute, that looks weird, right? Well, that's because it's got a different stretch on it. So you want to apply a different stretch to each channel. So you're going to hit Control and click on there, and there you go. So now that individually stretched it into each channel to give you a more balanced, natural looking stretch for your color image. So the next step, I changed the identifier for this to let me know that this is my color image. You want to keep these identifiers short and sweet and easily identifiable. That's because later on we're going to be using pixel math, and you don't want to be typing out very long names. So the next step is to calibrate the colors in here. I like to use photometric color calibration. This is broadband data, so you're going to work with that. You can just hit acquire data from image. As long as the information is within 50%, like 50% accurate, then it should work. You can find your focal length and pixel size from going to telescope.lot, like that. Go to telescope network, observatory, and then you're going to pick your telescope that you used. You can go to more info, and here's your information on the telescope, and what you're looking for is your focal length, 3962, and then your pixel size of 12 microns. Enter in 3962 and 12 microns, and apply it to the image. Okay, so now the photometric color calibration is completed. You can see the white balance functions and what it had done. Don't need that. Minimize that, and then apply a new stretch. That should have balanced out the color channels on our image. So the next step is some denoise. To do that, we're going to use multi-scale linear transform. We're going to do that. I like to use 5 layers for this, And because we have a separate luminance channel, we can be fairly aggressive with our noise reduction on the color data, because this is just going to put color. All of our detail is going to come from the luminance. So we want to mask off this galaxy first. Now there's two ways. You can make your own mask using range selection or making a copy, stretching it, etc. Or you can use this function here, linear mask. But you need to undo the stretch in order for this to work. Click linear mask, preview mask, and then live preview. And then you can see we have an inverted mask image, and you can see the galaxy and the arms. And you want to make sure that you're using just enough amplification to protect the parts you want to protect and the stars, but that's it. You don't want to be protecting areas of the background that you don't want to protect. That's where your noise is hiding. Then you want to add a little bit of smoothness so it's not a harsh edge. Just till you get like a little bit of a blur effect on there is what I find works best for me. Once that's completed, unclick pre-mask, press F12 to apply your stretch again. And we're back to that. Now if you're worried if it's looking really blurry or weird, you can go to quality here and just pick one of these. If you go maximum, it's going to sharpen it right up. Don't worry so much about that, as this image is not going to be blurry as this will be. So you go to noise reduction. Now play around with these numbers, these values, as they can change from image to image. This is just what I use as a default. Not necessarily the best way, but it's worked for me. Again, like I said, this is color data, so you can be fairly aggressive with the noise reduction. So this is what I use. So 5 for threshold, 3, 2.5, 1.5, and then values for amount would be 1, 9, 8, 8, and 7. Once you have that entered, you just hit the blue square to apply. And as you can see, it's starting to do its noise reduction. Okay, now the noise reduction is complete. We can carry on. And you can see before all the grain and after, and virtually gone. You can see it in the background before, or the after, and that's before. There is some hot pixels in here that I notice. There is multiple ways to remove them. The best way to remove them is through cosmetic correction. I guess I did not remove them completely, but that's okay. So once you're completed there, it's time to stretch. So we're going to go now from non-linear, or from linear to non-linear. So undo your stretch, F12. And the way I like to do it is using histogram transformation first. Reset and track. Click the check mark to track the image. Apply your live preview. And then you take this middle slider and you slide it just to the edge there. And you get a nice big stretch like that. And you want to do this iteratively, so you don't overstretch or understretch. And then I bring it up to here. I come back and you see how these numbers change. When you go this way, the number is starting to go up. These numbers here, that means you are clipping your darks, and you don't want to do that, so you want to back that off. Right? Now there is a little bit of noise in there, and that's fine. When you're seeing a number like that and it's just kind of sitting there like that for a little bit, I find that that's just a little bit of background color noise, and that should be fine. So I leave it there, and I'm going to bring that stretch back up to about here. So we're not completed yet. Reset that. The next thing I like to do is arc sine stretch. Now I like to use this one because it just seems to give me a more neutral stretch without any kind of artifacts showing up or introducing noise. I get a little bit better control. So I like to adjust the black point. Now another nice thing about this is when you start clipping, let's see if I can show you here. When you start, there we go. When you start really clipping it, you'll get all this stuff. This is showing what pixels have been clipped in the image. If you start seeing that, then that's not good. So I like to bring it down. This will vary. I do this iteratively as well. I don't like to stretch it too much in here, just a little bit, until I start getting the details in the cores on galaxies or some prominent figures in a nebula or something like that. And again, I do this iteratively as well. So I'm going to bring this black point down, because that background is just way too bright. So you want to get up to a point somewhere like that. Somewhere around here is usually pretty good. The next step, RGB working space, just ones across the board. I do this as a safety precaution because you're going to extract the luminance of this image. Not your luminance picture, but the luminance of this file. And then we like to put, I like to put a bit of a curves transformation just to make it more contrasty, so you can get a little bit better separation between the background and what you want to protect. So it doesn't have to look pretty, it just needs a good separation. Click apply. And now you have your luminance here. So you're going to take this file, you're going to drag and drop like that, and you see how it went all red. That's showing that a mask was applied. If you click this button, this is your invert mask. Now red is protecting, everything else is going to be affected. You can turn off the visibility of the mask. And we're going to do a round of TGV de-noise. I usually just use a very standard approach with this. I go 300 iterations and automatic convergence for both lightness and chrominance. This is not necessarily the best way, but this is the way that I like to do it. The way I process my images is more for aesthetics and looks than it is for scientific value. If you're after scientific value, then my tutorials may not be the best fit for yourself. I enjoy the objects for their beauty, and I use it to promote more interest into astronomy and astrophotography, astrophysics. I use these images, these well processed images, to try and get more public interest. So they don't hold as much scientific value as maybe some other people's processes. But if your goal is just to make some nice pictures for your backgrounds on your computer or your cell phone, or to have a couple nice wall prints, then this may be the tutorials that you would like to follow. Okay, so now that TGV de-noise is completed doing its process, you can see it just cleans it up just a little bit more. You can see, I don't know if you'll be able to see, but it's a little bit of grain there, and then after it just smooths that out and gives you a nice flat background. So now we can remove this mask, and the last thing I like to do is run SCNR on my color. Drops any little bit of green cast out of the image. It makes your blues a little nicer, all that stuff. So now we're done working on our RGB data for the moment. So the next process is working on luminance. So to do the luminance, the first thing I like to do is deconvolute the image. It's a little bit more complicated, and it tends to confuse people, so I'll go in this process quite slow. So you want to make a clone of this image, and you're going to use this to make a deconvolution mask. You're going to stretch this image. It doesn't have to be a pretty stretch or anything like that. Again, this is going to work just like the mask for TGV de-noise did. You're going to stretch this out to get a very good separation between what you want to protect and what you are trying to not protect, I guess. So you need a really good separation. It's okay to clip. Again, like I said, this is not supposed to be pretty or anything like that. This is a mask. We'll rename this Decon Mask, and we'll minimize that and put it away for now. Next, we need a local de-ringing support image. To do that, you make a star mask, and the settings I like to use is a large scale growth of 1, scale 6, smoothness factor of 10, aggregate, and de-linearize. And then you apply that to the image. Okay, so our star mask is done. That looks about right. You're only trying to protect the brightest and biggest of stars with this LDSI. Local de-ringing support image. The next part that we need is a point spread function. Easy way to do this that makes it work so much faster. Put a little preview into the box using this one and click into that. Just go into the very center of the image. Now you want to make sure that you have this script from Hartman v. Borman, and it is render PSF image. We're going to create a PSF image. Click evaluate. And this is the settings that I like to use: an amplitude of 0.65 for max, minimum 0.10, and a maximum number of stars of about 50, which should give us a pretty good representation of the stars. you're satisfied, okay, create, and hit OK. And now we have our PSF. So it's always best to work in preview. It just works way faster. I'm going to apply the decon mask, and it gets applied to the preview as well. And you want to make it the brightness this time, and you want to protect the background. So we don't need to see the mask. It's still applied. You can see that it's still applied. We're going to open up deconvolution. We're going to use external PSF, and we're going to click on our PSF image. We're going to use regularized Richardson-Lucy, and we're going to do, we'll start with about 25 iterations. Global dark, you want this to be as small as a number as you can without causing any damage or improper iterations. You'll see. So I like to start with about 0.05. Click local deringing and select your LDSI image, and then apply. Now what you're watching for is in the console. You want to watch the iterations and make sure that you don't have any warnings come up. You want a smooth iterative process completing. Like local, there we go, local divergence at iteration 5, so that's not good. So we're going to cancel this one. Now how do you fix that? You adjust your global dark. So instead of 0.05, let's try 0.03. Okay, so 0.03 worked. Now let's show you what this does. So you're going to see, watching the stars, that it sharpens everything up. Actually, 0.03 isn't working perfectly either. You can see that even in the galaxy that it's really adding a lot of sharpness to it. What deconvolution is doing is it's kind of representing the stars. I can't remember exactly how it goes. Basically, it's gonna take care of some of the atmospheric distortions and things like that. It's gonna take care of little I don't know. It sharpens the image, is basically what it does. Like I said, I'm by far not no expert on what exactly these processes are doing. For that, I recommend going to some of the other tutors, such as Nick Simonek or Adam Block. They are far more knowledgeable on the actual terminology and what these processes are. Okay, so 0.01 was the final amount that I required. So once your deconvolution process is complete, you can remove the mask by clicking that button and delete the preview by clicking this one. The next step is to denoise this image. So we're going to take that and we're going to go to multi-scale linear transform. We'll use the preview mask function again. Live preview. And we're going to make sure that we are getting lots of this galaxy and the arms all into play here, because we don't want to lose the detail in these arms and the galaxy core itself. So that should do. Make sure that it's got a nice smoothness factor to it. And then turn off preview mask and put your stretch back on. Okay, so TGV denoise is now complete. We can remove that mask, and now we have our luminance and our RGB files completed. So now we want to put those both together, so we're going to use LRGB combination. I'm going to deselect the RGB files and select your superluminance. And then you're going to hit apply. Apply global. Right. You're going to apply that to your color image. And there's the magic. So before, there's before, after. It brings out all the detail. From this point on, you are now at a nonlinear state. You can do some sharpening, star reduction, and contrast, saturation, and HDR, etc. So I hope you enjoyed this tutorial. Stay tuned for part 3, where I'll go through some more advanced things in the post-processing portion of this. I hope you enjoy. Take care.